Vidya can start, I think.
Yes, that's right. So, good evening, everyone, and warm welcome to all the participants in Faculty Development Program on Multivariate Data Analysis and Structural Equation Modeling using SPSS. This is the fourth day of the 5 day session, and this Faculty Development Program organized by Bharatiya Vidya Bhavan Institute of Management Science, Kolkata, in association with SPSS and Indian Economic Association. Today is the topic is your discriminant analysis and logistic regression, and the speaker for today is Dr. Rabindra Kumar Jena, Professor and Area Chairperson, IT and Analytics, Business Analytics and Information Systems, Institute of Management Technology, Nagpur. Thank you, sir, for joining us and accepting our invitation. We welcome you in this faculty development program. So you can start the session for today.
Okay, thank you, Sudipta. Thank you very much. And this is the sessions are towards the end of the FDP. I think the participant must have familiar with SPSS and its environment. So hoping to have a nice session today. Thank you. Just a minute, I'm sharing my screen.
Okay, sir. Okay.
Is it visible?
Yes, sir, it is
Yes, sir.
visible. Visible.
Okay, so very good evening to all. So today's topic we'll discuss today the logistic regression and discriminant analysis. This is the topic which is generally used. This is the technique generally used for classification problems. So this is the outline of my today's discussion. We'll first discuss about logistic regression, the basic overview how we do the logistic regression in SPSS. Then we can discuss how to interpret the results and write the results in APA format. Then we'll go for the discriminant analysis, and we will see how discriminant analysis can be used using SPSS and how you can write the results in APA format. That's all today's discussions. So I'll start from the logistic regressions. So we have already covered that linear regression, I think. So once you already cover this linear regressions, so there you might have noticed that the linear regression, we generally predict the continuous variable. That means the dependent variable is a continuous variable. But in case the dependent variable is not a continuous, is a your nominal or ordinal variable. So how can you predict that? In that case, you cannot apply the linear regressions. For that, we require another type of regressions that is called logistic regressions. So here the main point is that the dependent variable must be a category variables. So before going discuss more details about the logistic regression, just look at how that logistic regression is different from linear regressions. The linear regression is used to predict the continuous dependent variable using a given set of independent variables. But in case of logistic regressions, it is used to predict the categorical dependent variable using the set of independent variables. The linear regression is used for solving regression problems. But the logistic regression is used for solving classification problems. In this, we find the best fit lines. But in case of logistic regression, we will try to find the best S-curve. We'll discuss more about what is S-curve and how it is different from the fit line. The least square estimation method is generally used for estimation of the coefficients, also the estimation of the prediction accuracy. But in case of logistic regression, we use maximum likelihood estimator to find out the coefficients and also the estimate the accuracy of the model. It's require a linear relationship between dependent and independent variable. This is most important criteria or assumptions behind the linear regression, that the relation between dependent and independent variable must have linear. But in case of logistic regression, that is not mandatory. So we never check the linearity between the dependent and independent variable. That means in logistic regression, the assumptions is very less in compared to linear regression. Anytime if you face any problem, just raise your hand, so we'll discuss more details on that. You see in this example, see how that two regressions are different to each other. In this side, in the left hand side, you will see that this is the linear regression or OLS methods. In that things, we are predicting a continuous value based on the independent variables. And that can varies from minus infinity to plus infinity. But in case of logistic regression, our objective is to classify based on different classes. So we never expecting a numeric variable as an output. Therefore, we have used a functions, or we have used some functions which convert this numeric variable into 0 and 1 values in terms of probability. That's why the linear equation, whatever we got from this OLX or your linear regressions, that can be converted using some function into a S curve. As you see in that right hand side, the curve is known as S curve. It's starting, that means all the values lies between 0 and 1. All the probability values lies between 0 and 1. So in the regression, there are set of terminology generally used in the logistic regression. The first is the logistic function. The logistic function used to convert the numeric value into a probability value between 0 and 1. This formula is used to represent how the independent and dependent variable relate to each other, to one another, and the logistic function transform the input variable into a probability value between 0 and 1, which represent the likelihood of a dependent variable being either 0 or 1. In case of two classes, if there are many classes, then the likelihood of 0, 1 and something else in between. So this is generally the logistic function you use, that is 1 divided by 1 plus e to the power minus t. So that function, that sin t function, that function sigmoid function is used to convert the output into a S curve, and that the value is always between 0 and 1. So the logistic regressions, the main, that means that sigmoid functions is generally used as a logistic function for binary classification. We'll discuss more detail about. There are different functions available for logistic functions. So most frequently for binary classification, we use the sigmoid function. And then there is most important terms generally used in logistic regression, which you cannot find in the linear regression. That is called odds. It's a ratio of something occurring to something not occurring. This means what is occurring, what is not. That means it is basically related to how you classify your you classify the predictor based on the output value, either the 0 or 1, either 2 classes, 3 classes, 4 classes. So everywhere, either it is coming to the class or not coming to the class. So we have to define a probability of either coming to a particular class or not coming to a particular class. So the relation between these two is defined in terms of odds. That is called odd ratio. Take an example here. There you can understand clearly how you can define the odd ratio in logistic regression. If you don't understand odd ratio in logistic regression, you cannot analyze the output of logistic regression. Take an example. Here we have different variables. that variables, that means we have race, the sex, vegetarian, yes or no. And in that, we have two groups, that white and black. Then you see that, so suppose that there are with respect to gender, we have a male and female, and our output variable is vegetarian. Yes, that person is vegetarian or not vegetarian. So suppose if you see in the table, the male, that is 43 people male are vegetarian, 134 are not vegetarian, no vegetarian, and 134 is not vegetarian. Then the odd ratio, that means vegetarian to non-vegetarian, that is 43 divided by 143. That means 0.32. That means 0.32 means here you see that value is less than 1. So less than 1, it defines that the classes, the preferred classes, that is we started with yes. That means the odd of being vegetarian is always less than the non-vegetarians. Similarly for female, if you see the female 26 to 149. So that is 26 divided by 149, that is 0.147. It means that odd of vegetarian is less than the non-vegetarians. So if you combine both the things with respect to the white people, you say that the odd is 69 divided by 283, that is 0.244. Again, it's saying that for a white, there are more non-vegetarian than the vegetarian. So if that value is more than 1, then you can say the preferred group has advantages over the other groups. Suppose that for the subtotal of this white, if I find that it is more than 1, that I can say that there are more vegetarian than the non-vegetarian. Similarly for black. So the objective is that as we are predicting some classes or some that means nominal variables or ordinary variables using the regression equation, it is very important to know the importance of odd ratio. The coefficients. As you know that, like linear regression, our objective is to find out some coefficients. Using that coefficients, you can build a regression equation which can be used to predict the value for future. Similarly, in logistic regressions models, so there are different coefficients. Using that coefficients, you can find a equation which equation can predict whether based on some input value, that is the independent variables value, we can find out what class the dependent value or predict the classes. Then maximum likelihood estimator, the method used to estimate the coefficient of the logistic regression model, which maximize the likelihood of observing a data in a given models. So that suppose if you compare to the linear regression models, there here is the maximum likelihood functions, that estimator is a probabilistic function. So our objective is given set of independent variable value, how likely the function or how likely the equation, logistic regression regression, find a suitable group in the dependent variables. Logistic regression does not, then there are some set of assumptions before you doing any type of statistical calculation or statistical models. Though for the logistic regression does not assume a linear relationship between the independent and dependent variables, as opposed to the linear regression model. Second, the independent variable need not be interval, nor normal distributed, nor linearly related, nor equal variance within each group. These are whatever this, that first of all saying that independent variable may be both ratio variable or numeric variable, or it is a category variable. There is nothing, no objection or no restriction on that. Second, if you remember in the linear regressions, that each of the independent variable must be normally distributed. But here that constraint is not there. Second, there also the linear, that means the dependent and independent variable must have linearly linear relationship. But in the logistic, we also don't care about that. There also, we are assuming that the variances comes from the variable says equal variances with each group, within each groups. Here also, we don't consider that. So that means you can say that for logistic regression, we don't have so much restrictions. Then homoscedasticity is not required here. The homoscedasticity is one of the major problem in linear regressions. It says that how your error terms are behave with the predictions. So there it should be some, it should not follow pattern, it should be some normally distributed. But here we don't consider this, we don't bother about this characteristics because our dependent variable is a class variable, not a numeric variable. That's why you don't consider the homoscedasticity here. The dependent variable logistic regression is not measured on an interval or scale. The dependent variable must be dichotomous. We are talking about binary logistic regression. We'll see there are different types of logistic regressions. So here that condition is for only binary logistic regression. Binary means the category of dependent variable have only two alternatives, two classes. The category groups is the independent variable must be mutually exclusive and exhaustive. So one condition is that the groups in the dependent variable, they must have mutually exclusive and exhaustive. A case cannot be in one group and every case must be a member of any of this group. This is the condition. That is the most important condition for the dependent variable in logistic regression, that is category variable. You require the sample size. In compared to the linear regression, the logistic regression require more sample size. Some of these references I quoting here, that means larger samples are needed in comparison to linear regressions. Holmesers and their colleagues, they suggested that minimum sample of 10 per observations, 10 per independent variable is required. But if you have more than that, it is good because the sample size, if there are large sample size, that means the probability of classifying into groups will be more, and it will be more clear. That's why it is assumed that so per independent variable, suppose you have 5 independent variables, so then you must have at least 100 to 150 sample size. Okay, then we'll start the modeling. So first, how to start the logistic regression model? First, you have to define the problem. So defining problem lies in how to find out which are the dependent variable, which are the independent variable. And mind it, for dependent variable, it should be a class variable or it should be a category variable. Data preparation, mainly cleaning process of the data, make sure data suitable for logistic regression. Main observation or main thing in the data cleaning for the logistic regression that it is highly biased. It is highly biased to the outliers. So try to remove the outliers. Visualize the relation dependent and independent, identify any outliers and anomalies in data. So majorly, so as there are not many assumptions behind that logistic regressions, main problem is with the outliers. So try to remove all the outliers from the data. Secondly, try to minimize the missing values. Although the regression analysis, even though you have missing values in the data sets, while performing the logistic regression, the system automatically removes all the missing values. Then building the models. So what happens in all the classes of prediction classification models? So the data set generally divided into two parts. One is the training part, another is the testing parts. Generally, we are making it 70 to 30 ratios. 70% of data will be in training and 30% generally used for testing. Model evaluation. So then once you build a model using that logistic regression, so you have to find out how you can measure the performance of the models. So the performance of the logistic model generally use different matrices. So first one is accuracy, precision, recall, or F1 score. We'll detail discuss how do you find out this in the next slide. So once you build the model and you find that the accuracy is not up to date, not up to your expectations, what will do? You have to fine tune your independent variables. You can add some new variables. You can remove some of the variables from the independent list. So that objective is to improve the. So once you satisfied with that model performance, now this is time to deploy the models. So that deployment of model generally used to predict the classes for new variables, new data. So different steps you should follow to build a logistic model. So take this example because it is very essential, very crucial to find the efficiency of your model. So suppose that I have suppose that I have a table in that binary classification. So there are two output classes. One is class yes or class no. So there are two things: actual values and predicted values. So in the vertical lines, vertical things, we are making the predicted classes, and the horizontal we have actual classes. That means you see in that A, that is TP, that is called true positive. The true positive, it says that so the value was true, but my algorithm also predicted it's true. That's why it is called true positive. And B, you see the false negative. So actually it was true, but my algorithm or my model classify as no or false. So that's why it is called false negative. Similarly, for C, it is called false positive. Actually, it is no, but my algorithm predicted is yes. That's why it is called false positive. Similarly, D, that is called true negative. That means my algorithm predicted no, actually it is no. So that's why all the predictions is defined in 4 quadrant if it is binary classification. Based on these values, we can find out different matrices or different performance indicators. So let's see. Accuracy, the portion of the total number of predictions that were correctly predicted. Here, how many has correctly predicted? That is true positive and true negative. These are correctly predicted. So the accuracy will be A plus B divided by A plus B plus C plus D. So the accuracy of this algorithm, if you find this value, A plus B divided by A plus B plus C plus D. This is called accuracy. The next is called precision. That is the portion of positive cases that were correctly classified. The portion of positive cases means yes, that has correctly classified. That is A divided by A by B, A by C. Correctly classified by your algorithms. So how many has correctly classified yes in our algorithm? A and C. But out of this A and C, how many are correct? That is true positive, that is A. So precision is A divided by A plus C. Precision generally either to the type 2 error. Then negative predicted value, the portion of negative, the proportion of negative cases that were correctly classified. Negative cases means no cases. So no cases that is corrected, that is D divided by B plus D. Total negative cases predicted by my algorithm is B plus D. So out of which D is true or D is true. That's why it is D divided by D plus D. So this is called negative predicted values. Then sensitivity or recall, the portion of actual positive cases which are correctly identified. This is the proportion of actual positive cases which are correctly classified. Portion of which are positive cases kitna hai? 1A plus B. So how many has correctly classified? That is A divided by A plus B. So A divided by A plus B is called sensitivity or recall. So finally, there is another matrices generally used for find the performance of a logistic regression. That is called specificity. Specificity is the portion of actual negative cases which are correctly identified. There are negative cases. How many negative cases there? C plus D. Out of C plus D, how many has correctly identified? D. So that specificity is D divided by C plus D. So once you got all these things, finally you can have your F measure. F measure is nothing but 2 into true positive divided by 2 into 2 positives plus false positive plus false negative. So these are the formula generally used to find out the value of different performance criteria. I hope you understood, because it is essential to compare different models which is used for logistic regressions. Next. So there are different types of logistic regressions. Generally binary logistic regression, multinomial logistic regression, ordinal logistic regression. So binary logistic regression, it says that the category variable has only two labels or two categories like yes or no. So it has only two categories. Multinomial logistic regression, it says that if the binary, the category variable in the dependent has more than two classes, that is there you cannot apply the binary logistic regression. You have to go for multinomial logistic regression. Example, suppose we have different options. Yes, no, cannot say. Yes, no. Suppose you ask some question, the answer will be in three groups. Yes, no, or can't say. So here this is three groups. So if there are more than two groups as an independent variable, you have to apply multinomial logistic regression. Then ordinal logistic regression. If the dependent variable which are ordinal, that means it has some orders in that classes. Yes or no, there is no order. You can say yes, no, no, yes, there is no order. But if you say that, suppose that take example that your output variable is a ordinal, is a category variable, where you say that prefer, I prefer, I don't prefer. So there is some order, or first, second, third. First, second, third. Suppose there are three classes in a dependent variable. So you cannot use that binary or multinomial regression. There you have to go for ordinal logistic regression. Ordinal logistic regression, the name suggests that the output variable or dependent variable has classes. Either it can be a binary or multinomial, but the classes has an order. So and so we'll go and see how we can do it using that SPSS. So I already shared you some files, so you can get download this from that chart sections. So if you have not already done, kindly do it. So we'll use first. It is not HD. I renamed it. That is logistic regression, I think. So once you're ready, I should start. Waiting for a response whether you have downloaded the file and open this file in your SPSS. Have you done it? Waiting for your response, if any.
Can you repeat, sir?
So I have shared two files.
Okay.
So these files should be downloaded.
Okay. I'm just sharing, sir. I'm just sharing with the participants.
So once they download, we can use one by one files.
Sir, sir, have you just shared? Because
no, I shared that before 7.
Actually, I have not received, sir.
Okay, so
Please
let's share
resend it, sir.
now. Okay. Let's share me now.
Yes.
Okay.
Yes.
So can I share using that chat? Right?
You can try, sir. You can try, because always we are sharing through
In the
email.
chat.
I think you can share.
Okay. You require to share me by mail.
Please, that will be better, sir.
Sudipto, can I share using my mail?
Yes, sir. Yes, sir. Please.
Okay, 1 minute. One is just a minute. Some.
Yes.
Yes, yes, sir. Yes, sir. Audible.
Just share it.
I'm facing some network issue. Sir, have you
Okay.
shared through email?
Yes.
So just give me 1 minute.
Yes, please.
Excuse me, sir. Excuse me, sir.
Yes.
Okay, shall we open the SPSS?
Yeah.
Okay.
So these 3 files, that 4 files, I mailed you. Just share with that. Sudipta, can you?
Yes, sir. I'm just doing that. Done.
Okay, hope everyone get it. So just open the first one, that is called Logistic Regression.sab.
Oh, excuse me, sir. From where I have to get it? That in mail?
Yes,
Yeah,
yes,
I mailed you.
yes.
Wait, so just wait a minute. I will
Just
see that.
just check. We have just shared with you through email.
Okay, sir.
If you have not received in inbox, just check your spam folder also. The subject
Okay, sir.
line is materials 4th day. Okay.
Okay, sir. Okay, sir. Okay.
I think you can start, sir.
Right. Okay, so everyone kindly download that file and just open that file, what is called Logistic Regression.sab. And that file we are using for doing that binary logistic regressions. So that file has this many variables, that is gender, that is a dichotomous variables, that is male and female. Age is a continuous, that BMI index of that person, heart rate of that particular participants, and glucose level. So these are all our independent variables. Out of these 5 independent variables, 4 are continuous and 1 gender is our category variable. So our output variable is to find out the risk of heart disease, HD. So HD is our output variable, that is the risk of heart disease. Our objective is to classify the participants based on their gender, their age, their BMI index, their heart rate, and glucose intake, to determine whether that set of data will classify the particular person as having heart disease or not having heart disease. That is our objective. So the research question for this data sets, we want to find the answer to these following questions. What are the factors predict the heart disease among people? So based on that, our research question is find out the factors which predicts the heart disease among people. Second, what are the performance indicator of the models? So how robustly the data support that model we build, that is based on different performance indicators. So with this research question, we can also frame some hypotheses. The hypothesis says that, so it's saying that so how significantly the independent variable predict the dependent variable. How significantly gender, age, BMI index, heart rate, glucose level of a person predict the heart disease. This is our hypothesis. So we are trying to answer this resource question, also trying to validate our hypothesis. Then, so some of the assumptions we require for this logistic regression. The first is multicollinearity. It's not required, but you can check if you find there is no multicollinearity, you might have get some good performance matrices. Otherwise, don't bother about this in a logistic regression. Multicollinearity says that whether that dependent variables are highly correlated to each other. It's required because if you have more than one numeric variable in your independent list, so it is always good to find out their correlations, whether this numeric variable has some issue of multicollinearity or not. So how do you find out? There are different indicators. If the correlations between this independent variable is in more than 0.7, then there is a serious concern regarding this multicollinearity. Or you can also have the variation inflation factors, that is VIF. So for if the VIF is greater than 10, sometime for good models you can try it for greater than 5. If it is greater than 5 or greater than 10, you must have the issue with the multicollinearity with that. Or otherwise your tolerance level. The tolerance must be greater than 0.01. If it is less than 0.01, means there is a serious issue with the multicollinearity of the data. So try to find out this. Then outliers. So as I told, that outlier has a that is very serious problem in logistic regressions, even if any statistical methods or modeling. So try to remove all the outliers from the data. Sample size. So sample, as I told you, the sample size must have significant enough to validate your logistic regression model. So for suppose we have how many independent variables? We have around 5 independent variables. So at least we require if each independent variable has 10 samples, then it is required at least 50. So if you take 20, it should be require more than 100. So more sample size, it's better to validate our model. So then how do I apply it? So if you already open that, then you can follow me with that SPSS. So I can open the file now. Open the file. The file is in data. So now I am opening the logistic regression. Okay. So can you see my screen? Is it visible?
Yes, sir, it is
only
visible.
Sir, only
PPT
PPT
is visible.
No, sir,
Sir,
not
the PPT is visible only, sir. It's not moving.
It is not moving, sir. Your
So just close
SPSS
the
we cannot.
PPT.
Well, just a minute, just a minute,
Yeah.
just a minute. So goes what not that SPSS is not seen?
No, sir, just close the PPT, sir.
Okay, so
So you need to share the whole screen. You just shared the PPT. That's
okay.
why it's not
Okay.
moving. So
Okay.
just close the sharing and start resharing, sir. Screen. Stop sharing now. After that, start resharing.
Now no.
Yes, sir, it is visible now.
Now it's visible, sir.
Okay, okay. So this file we are using for this. So we have how many variables? There are ID is just for identification of the cases. So we don't require that. We don't use that. So we have gender, age, BMI index, heart rate, and glucose. These are independent variable. That dependent variable that is called HD. So if you see the HD value here, these two labels, that is in yes or no. So you have to remark, that means before logistic regression, you should remember. So what is stands 0, what is stands 1? They have important significance when we go for analyze. So just remember, 0 is no, 1 is yes. Similarly, for gender, you have to remember what is for 0, what is for 1. 0 for male, 1 for female. Because if you don't remember this classification of these different groups in that category variable, it is very difficult to analyze the regression model. So before that, you have to remember all these groups. So you see the data. These are data. There are enough data. Sample size is more than 4,000. So we don't have any issues with the sample size. The sample size is more than 4,000. Now what will do? Just go for analyze. In that analyze, go for regression.
Sir, your that cursor is not showing, sir.
Not showing. Cursor is not showing. No.
Yeah, it just only opening the SPSS that.
Okay. Okay. Let me again reshare. I'm just stop sharing. Stop share. And I will sharing again. Okay.
Now it's showing, sir. Now it's showing.
Okay.
Your cursors
Now.
are moving.
Oh,
Cursor is
okay,
moving,
sir.
sir.
Okay.
Okay. Then regression. In the regression, go for binary logistic.
Excuse me, sir. Please do from the beginning so that.
Okay. So open this file. This is in data view. These are the data. Got it?
Okay, sir.
Yes, sir.
Okay.
Yes.
Okay. Then go analyze. In that analyze, you will find your option that is called regression. In that regression, find out the binary logistic regression. Right? Did you get it?
Yes, sir.
Then click it. Then you will get a box like this. So in that box, what is our independent variable? Our independent variable is HD, whether they have heart disease or not. So take it into the box that is called dependent list. And other variables like gender to glucose level. So bring it to the covariates or independent variable. Right? So once you did it, you see that our independent variable, one variable of the independent list is a category variable. So just click on categorical and take that independent variable which is category in nature, that is gender. Okay, in the gender, the reference category is first. So first reference category means no, that is 0. 0 is the first, 1 is the second. So our reference category is 0, means no heart disease. So our analysis will take place heart disease with respect to 0 is the male and 1 is female with respect to female, because male is our reference, means basic categories. So take it, you did it, take that category variable gender into that covariant list, then continue. Right? Then go for save. उसमें क्या होगा? You have to save the membership probabilities and then give a file. That means that result, that means all the equation, whatever it is derived from this regression equation will save in a file, so that file can be used further to predict the new data. So you just go and give any suppose that here I give a file name, let's say logistic regression. So I give the file name means the result, all the equation will store in logistic regression file and save it. Then continue. Then you go for option. In the option, you have to click on Hosmer's goodness of it and CI of that confidence interval of EXPB, that is your odd ratio, and correlation of estimates, and let them others as it is. Then continue. Right? This all. Then you have to okay. And you will get the results. Did you get it? Everyone? Once you finish, I'll go for analyze one by one table. So you must have these tables before going ahead. So let me know. Should I move forward? Right? Should I move? Okay. So now I'm going to my PPT. PPT is visible now?
Yes, sir, it is visible.
Okay. So now let's see the result. You must have get a case processing summary in your SPSS sheet. So I'm putting that sheet here and see that. You see that what you'll see. You see that the missing cases, there are 403 missing cases generally that has been removed by the system itself from total of 4283. So missing cases has been removed. Next, we will find this one in the dependent variable encoding and categorical variable encoding. In dependent variable encoding, no stand for 0, yes stand for 1. No means no heart disease. 1 means yes, the heart disease, there is a heart disease. And then in categorical variable, we have gender, that is male and female. So male is our reference group, female is our the group. We have to find out the chance of female to have a heart disease with reference to the male. So this is all about. The next is block 0. So in the result, you see there are two blocks, block 0 and block 1. Block 0 generally used to find out if you don't include any of these independent variable to predict the dependent variable, only include the constant terms. What is the situation? In that you see that the result of the analysis without any independent variable, it serves as you the baseline for comparing your model after including the independent variable with the model which does not have any independent variable. In the classification table, you see that the percentage of classification is only 58.8. That is the accuracy. 58.8 percentage of data has been classified accurately. Where the model used the existing model don't use the independent variable. Now this is for reference, means we are not including any independent variable. Then after adding that independent variable to the list, let's see. The equation in comparing model is, does the log likelihood increase or decrease significantly with addition or deletion of variable? So if you remember that linear regressions. So how do you measure this? Increase or decrease of significant, increase or decrease of the performance of the regression while adding or deletion of a variable. How do you know that? In in your linear regression, that is observed by seeing the value of adjusted R square. The adjusted R square value say you whether by adding or deleting a variable from the independent list can improve the accuracy, improve the fitness of the line or not. But here we are not using the adjusted R-square. Rather, we are using log likelihood functions. The common first step in the analysis of logistic regression is to compare the constant only model with the full model. Constant only model, whatever we saw in the last slide, means without taking any independent variable. Full model means with taking all the independent variable at a time. If no improvement is found, then all the independent variables that are added, means if there is no improvement after adding the independent variable to the equation, then we'll say that that independent variable has no effect or impact on the dependent variable. SPSS will do this by test for you with constant only versus full model analysis. So in the model, you can have the chi-square test, chi-square omnibus test model of coefficients. You see that. In that block one means that is block 0 without including the independent variable. Block 1 including the independent variable, all are independent variables are included. So you see that the significant variable, if the significant values, that's a significant value is less than 0.05, if you consider 95 confidence interval, then it say that the model is significant and all the independent variable has some significant impact on the dependent variable. So it also says that independent variable, after adding the independent variable to the list, it have a impact on that dependent variable. So here we see that there are three types: block and final. We are all these values have same values because we taken all the independent variable at a time. So block, we have not defined any block. So block and final are same. Then we have to go for the next test, the Osmer test. And it says the null hypothesis that prediction made by the model fit perfectly with observed group of membership. That means, so whatever membership is predicted by the model, it is actually the same membership. Means how much, that means how correctly your model predicted that values in that. So here, if the significant values is greater than 0.05, that means your model has significantly predicted the classes of dependent variable correctly. So in our case, the significant variable is 0.773, which is greater than 0.05. That means the null hypothesis is accepted here. What is the null hypothesis? The null hypothesis is that the prediction made by model fit perfectly with the observed group membership. So by adding independent variable, whatever prediction we are getting, that is perfectly fit with the actual membership values. Then we'll find out how well does the model performs. So unlike linear regression,
can you show the previous slide ones? This one, not before that, before block 1.
Right.
So the previous slide. Okay, sir. Thank you.
Right. So now,
Yes, sir.
so generally the model fit is in the logistic regression. How do you find the model fit? In logistic regression, the model fit is found by two criteria or two variables. One is the F values and the significance and the R-square values. So these are the determinant of the model fit of linear regression. But here in logistic regression, we don't have any R-square values. Rather, we have a pseudo R-square values. So SPSS provide two estimates which are similar to R square in logistic regression, in linear regression. One is Cox and Shell measure, that is based on the log likelihood and takes accounts of the sample size. However, it cannot achieve the maximum one. So you cannot have one, maximum one here. The second measure is Cox and Snell, so that the Nagle karke where the values can achieve one. So there are two measures of R square, pseudo R square in logistic regression, that is Cox and Snell and Nagel karke. So we'll see the result here. So you see that the Cox and Snell, it says that 62%. And Nagel karke is 0.83, means you can take it as well. That is the variance of the independent variable can be observed. That means that in the dependent variable can observe from 62% to 84%. The two values indicated that between 60.6 and 83.4% of the variance in the dependent variable can be explained by our independent variable which they are in our model. So these are similar to the R square value of the linear regression. Next, classification table. You see that in our block 0 classification table, the accuracy was 58.8. But in case of after adding all these variables, all our independent variable, the classification rate is now more than 90%. What does it mean? Means that after adding the independent variable to the list, the percentage, the accuracy of the model has enhanced. That means there is a point or there is a improvement in the regression equation by including the variables, independent variables. But like your linear regressions, even though model is good fit, but all the independent variable may not equally influence the dependent variable. In the same sense, in the logistic regression, so we have to find out which are the variables which have the significant influence in the dependent variable. So in linear regressions, there we generally see the t-test. But here we are checking with WALD test, WALD test. Right. And any values which is less than 0.05, if you take confidence interval of 95%, then that variable has a impact on the dependent variable. So if you see in that age that significant variable is less than 0.001, means it is less than 0.05. That means age of a person has an impact on whether he is having a heart disease or not. Then if you see that in that in linear regression, the unstandardized coefficient, that is B, generally used to define the regression equation. Similarly, in logistic regression, the coefficient B is taken as the coefficient of the logistic regression equation. Here the value is 0.045. It is positive. The age value is positive. So if the age value is positive, that means that when the age is increases, then there is a chance of getting the heart disease. Then you comes to the exponential B. The exponential B is nothing but it is called odd ratio. Whatever we discussed previously, introduction section. This is called odd ratio. So you see that odd ratio of age means is greater than 1. It means that if you increase the age, the risk of heart disease increases 4%. The rate of heart disease or getting heart disease is increases by 4%. Similarly, comes to the BMI index. BMI index, the significant value is greater than 0.05. That means that variable does not have any significant impact on the classification on the dependent variable. Heart rate also does not have any impact. Glucose level also does not have any impact. The first things you feel that the gender coefficient of gender is positive. So that means if you increase from 0 is male, 1 is female. So if you move increasing, that means 0 to 1, the possibility of heart disease also increases. So how much it is increases? It is given by the odd ratio. The odd ratio is 5:8:1. So our reference is 0. 0 means male. But the value 5:8:1 is fine for gender 1. Gender 1 is the one value of gender is female. So we will see that how can you analyze the gender, that means category variable in this. You see that means for a female, getting a heart disease is 581 times more than being a male. So results showing that the female have 581 times chances to have heart disease in compared to male. So got my point? So here you are getting gender 1. Gender 1 stands for female. As I told you, it is very important to know the label of that category variable. 1 stands for female, 0 stands for male. So in this way, you can find out that female has 581 times more chance than a male to be to get the heart disease. Right? Hope you understand how to analyze all these things. Two important factors. One is B, another is significant level. Third one is EXPB. That is generally known as the odd ratio. Okay. So statistical significance in Indian variable. How can you write it here? You see that statistical significance in logistic regression is calculated with wall test. It is the square of logistic regression coefficient divided by its own standard error. So look at the significant column where P is greater than 0.01. Where P is greater than 0.015, that means that variable does not have any impact on the dependent variable. Then B is, as I told you, B is the logistic regression analogous to B is in linear regression. That is the coefficient of logistic regression equation. Check in sign in front of it will tell you the direction of the relation. If it is positive, it is increases. If it is negative, it will decreases by increasing the variable value. Then as I told you that EXP, it is the odd ratio. These odd ratio for each of the variable. Odd ratio greater than 1 indicated an increase in the odd of outcome of 1 with 1 unit change in the independent variable. Odd ratio less than 1 indicated that decrease in odds of an outcome of a 1 with one unit change in the independent variable. If the odd ratios remain 1, it says that means either of this group there is no impact or there is no difference. That means male and female both have same chance of getting heart disease if it is 1. Interpreting, and I already told you whatever written here. So the odd ratio of heart disease is 1.04 times higher for each unit increase in their age, where taking all other independent variables values same or constant. The odd of HD or heart disease for female is voting, so is in 581.59 times higher than their male counterparts. What already I told you. You have noticed that because I'm using the continuous variable to predict the dichotomous outcome, I am reporting the increase of odd for each unit increase in the independent variable, as I told you. If I are using the dichotomous independent variable, that is comparison to male to female or men to women, I would write it as a comparison to reference group. Where is the reference group? The reference group is the group which will be compared to find out the other groups. Here our reference group is male because we are finding our result with respect to the female. So here the female women are 581.19 times more likely to have a heart disease in compared to their male counterpart. So the odd ratio is the change of odd being whatever I told. If it is more than 1, then it is if you increase 1 unit, it will be increase the impact. If it is less than 1, it is decrease the impact. If it is 1, there is no change. Okay, so suppose an odd ratio is 0.8, it indicates that the outcome level 1, that is female, is 0.8 times likely have the heart disease with 1 unit increase in the predictors. In other words, the odd is decreased by 20%. Okay, so you see that the difference, the probability, EXB, that is odd ratio, is also a probability terms. If you compare the probability to odd ratio, the probability is always between 0 to 1. But the odd ratios can be go for 0 to infinite. So that is difference between odd ratio and probability. Probability always 0 to 1, but odd ratio can go from 0 to infinite. And then how can I present my results? Because these are the results which has been there in the SPSS sheet. But you cannot do all this. You cannot copy and paste all the tables here in your research paper or your thesis. So then the most important part, what you require to present in your results. That is how. So you have to see the table, create a table like this. Sorry. Main thing is that you have to represent the B, the standard error, significant values, and odd ratio. These are more important. And there the R square here, there are two R square value, that is Cox and Nell and Naglecker. So you have to mention at least these things to represent your results in your, and you have to find out that which one is your reference level. Here reference level is 1, means we will have a heart disease. No, it is not a reference is 0, then your result is based on probability of getting a heart disease, that is 1. Then comes to the performance. So performance is used to find out the accuracy or other factors which is used to find the performance of these things. You see that 94.8, the overall percent, that is indicate the accuracy of that. You see, this is called accuracy. So accuracy of the model is 94.8. Then you see that 97.8, that is called, that means the sensitivity of that. How good your algorithm is predicted the yes to yes. And then this one is called specificity. It says how well your algorithm predict no with respect to the original value. So these three are the most important factors, important criteria to find out how your model is performing. Then also from here, you can also find out other parameters like that means the F value, F measures. Because you see that it is all that true positive, true negative, true false positive, false negatives, like this 4 quadrant. Here, yes, no, like this, you have to find out. Then how do I write the result in FTA format? This is very important. What things to be added here so that anyone read your summary can understand how your logistic regression performed. So a logistic regression performed to find out the significant predictor of heart disease. This is the effect of age, gender, BMI, heart rate, and glucose on likelihood that participants have a heart disease. The logistic regression model was statistical significant. You have to write the chi-square values, which is significant because P is less than 0.05. The model explained 84.3 of the variance in heart disease and correctly classified 94.8 of the cases. Then you have to write female are 582 times more likely to exhibit heart disease than males. Further, increasing the age was associated with the increased likelihood of exhibiting the heart muscle. However, BMI, heart rate, glucose were not significant predictor of the heart disease. That's why what we frame the hypothesis. We frame the hypothesis that all the independent variables have a significant impact of the dependent variable. But here, finally, we can say that the hypothesis what we have presumed is partially corrected because only 2 variables have significant impact. Other variable do not have any significant variable impact. That's why our hypothesis is partially supported. Hope you understood this. Then, how do you predict that? How do you find that things? As other variable does not have an impact. We have only 2 variables. Gender and age has impact on the heart disease. So in our regression equation, logistic regression, we will keep that variable which have significant impact. So that's why we have to find out the B1 and B2 value which is there in the table and create an equation like this. After evaluating this equation with some values, we can get the probability of getting the heart disease or not. Any doubt? Then you just comes here and find out how I can use that value to predict new values, right? So suppose can you see the screen of SPSS?
No, sir.
No, sir.
Okay, so I'm again I am sharing it now.
Yes, sir.
Yes, sir.
Okay, now what I'll do, I will create a new file. In that new file, I'll put some values of that variable and let's see by using the equation whatever we obtained so far to predict a new variable or new set of variables. So then now a variable, I require that 2 variables only. What is that? Gender and age. These are the variables which has impact on that heart disease. So I create a new file here. Okay, in that new file, I can create these variables. Okay, now in the data view, I'll put some values here. So 0 for male, suppose the age is 35. Let's say 0, age is 56. Let's say it's a female, the age is 29. Let's say again there is a female, the age is 65. Now, based on the value, what will be my output? Whether if a person male and age 35, what is the probability to get a heart disease or not? Similarly, if the gender is a male and age is 56, what is the probability of getting a heart disease? All these things. Then what I'll do? So I already, if you remember, I saved the result in a file that is called Logistic Regression LG, I think. So you can go utility here.
Yeah, it's not showing up. Like, whatever changes you're making is not showing.
So the
It's
screen is not
static.
visible.
Now your screen is visible, but it's static. Like, whatever
Okay.
updates you're doing, it's not visible.
Right.
Sir, I will recommend you share the full screen So that's in that case, you will not face this problem
Okay,
again and
okay,
again.
right. Now it is visible.
Yes, sir. Now it is visible.
So what I said that suppose I have two variables, age, gender and age, I have some values. My objective is to find if these values are given to my equation, which I have derived from that, then what will be the output. Okay. Okay, I got 10 minutes. Okay. So go to the whatever you say here, it will come. So here it is showing that predictor 4 variables because I have taken the 4 variables, that is gender, age, BMI, heart rate, all these things is glucose. But we see that gender and age has only significant impact on that. Others don't have. So what will I do? So before making these things, I will go and rerun again the regression equation after removing all the variable which has no significant impact. What I'll do, I'll go through my previous screen. And go for the same steps, go for regression, and you go for binary logistic regression. What I'll do, I'll remove all these variables because this variable does not have any impact on that output. So I'll keep only these two things, and then I'll save the results, the same files. Okay, the same file. Or let's say to give another file, let's say LG1. So I'll put it okay, continue, and okay. So it's now all these things are there. So now I'll go again. I'll go again to that new files, that where I can put some values there. Here, then I'll go to utility. In utility scoring wizard, in the scoring wizard, you take the log one, which one is previous, and you see that you have only two variables, gender and age. Right? Then next. And you are showing that all these things. So it will take these two variables, and what are the variable of specifications, they are all given. Then next. Next, I have to give the predicted values. And I will say finish. Then you see that the predicted value, you see that means if the gender is male and age is 35, so it's giving 0, means no heart disease. If it is the male, if it is female and age is 29, the probability of being a heart disease is 82. That means it is possibility, the confidence is 82%. Similarly, if it is female and age is 65, age is more. As I said, that age, increasing age also increasing the probability of being heart attack. So it's increasing confidence. You can, is that okay? Should I move? Okay, so let's go for the presentation again. So we are here now. Now this is end of the logistic regression. So there are different regressions are there. Then you can use that like binary or logistic. Binary, we already completed the binary. We have multinomial and ordinal. So we'll see at the end. If you have time, then we can execute all these things. The files are available with you. Now go to the discriminant analysis. So the question is how discriminant analysis is different from logistic analysis. You see, in the discriminant analysis, the output variable is also a category variable as it is in logistic regression. Then you can say if the output is same, other terms are same, then how the discriminant analysis is different from logistic analysis. The first criteria is that if you compare with binary logistic regression, then in binary logistic regression, there are only two groups in output, like heart disease or not having heart disease, not having heart disease. Then if you have more than two groups in the output, then you cannot use the binary logistic regression. Then either you have to use multinomial or discriminant analysis. Both multinomial and the discriminant analysis, the output variable have more than two categories. Then the next question comes. Then how that multinomial logistic regressions and discriminant analysis differ? Here you can both use discriminant analysis and logistic multinomial logistic regression for doing the same thing. But the differentiation comes here if your independent variable has a category variable. Like in case of our binary logistic, we have an independent variable gender. Similarly, if you have a independent variable which are category, then multinomial logistic regression is better in compared to discriminant analysis. If the independent variables are all numeric, then the performance of discriminant analysis is better than the multinomial logistic regression. But you can do both the things for any data set if the output variable has more than two labels. That is the only difference. Otherwise, there is no other difference. That means the logistic regression will analyze more on the categorical variable of independent variable, whereas the efficiency of analyzing the numeric variable in the independent list more for the discriminant analysis. That is the only difference. Otherwise, you can either take the multinomial logistic regression or discriminant analysis alternately. So assumption is also linearity, because here the linearity assumption, because we are taking because all of our independent variables are continuous. If they are continuous, we have to see their relationship. So we have to check that they must be least correlated with each other. If there is a strong correlation between the independent variables, there may be a chance of overlapping effect on the dependent variables. So that will reduce the prediction power of the developed model. So it is essential to find the linearity as well as the multi-collinearity between the independent variables. Right, whatever I discussed. Then homogeneity of the variance covariance matrix. That means with respect to different output labels, the independent variables must have same variance or similar variance across all the groups of the dependent variable. So how do we find out it? In discriminant analysis, there is a test that is called box M. See, box M test generally define whether there is a covariance, the homogeneity in the covariance or not. A alpha level of 0.001 or less than 0.5, say that of level of 0.05, if you are taken 95 confidence interval is recommended, or If you take that alpha here 0.01, that is good, very good. Multicollinearity we already discussed. So test of significance. For two groups, the null hypothesis is that the mean of two groups of the discriminant functions. Here, how do you discriminate the functions? What is the main object? Discriminant analysis means the output. We are getting different classes. So how the classes develop in discriminant analysis? That is based on the distance from a particular point. And that point is known as centroid. So a point which is close to the centroid of a particular class, that means that variable or that point is belongs to that particular classes. So the centroids are the mean discriminant score of each group. Wilkie lambda is used to test the significant difference between the groups. If lambda value is significant, means there is a significant difference between the groups. There is no overlapping. Our objective is to find out, is there any overlapping between the classified classes or classified groups. The weekly lambda between 0 to 1, it tells us that the variance of dependent variable is not explained by the discriminant functions. Means it should be greater than 1. The lambda value is for test of significance difference between this group of these things, whatever I said. That means it should be significant to have to conclude that the output, what we are getting, are significantly different to each other. So for two groups, the null I already discussed. Example. So we have one data file that is called discriminant SAB. There are 244 observations in that. So the output variable, here you see that output variable has 3 labels: outdoor, social, and conservatives. And there is a category variable in the independent list that is called label. What type of service? Mechanical, dispatcher, or mechanics, customer service, dispatch, and mechanic. So based on, if you see the data here, I am moving to the SPSS again, and I am opening that. That I'm so I'm loading that new file data. Then just a minute. So open that file. What I shared with you, that is that discriminant analysis file. And this is the discriminant analysis file. Did you see my screen? So objective
Yes,
is
sir,
that,
it is visible.
is it visible?
Yes, sir.
So the objective is that I have to find out, if you go for this variable view. So my objective is to find out that the JID, the values, description of the job. There are 3 types of jobs: mechanic, service, and dispatcher. So based on this independent variable, that is outdoor, social, conservative, job, I have to determine what are the type of job he or she can opt for. We are predicting this. So then what I'll do? So go for analyze. In analysis, go for classify. Go for classify. Don't go for regression. Go for classify. In that classify, you will find option is discriminant. Go for the discriminant. In the discriminant, so my objective is to find out the job. So this is your job. So define the value. Job का value क्या है? 1, 2, 3. If you see the value of job, you see it is 1, 2 or 3. So define the range. Minimum is 1, maximum is 3. Continue. Then take other variables as independent variable. Right? Then go for statistics. So check here box M. Unstandardized. Within groups. Total covariance. Or you can also have mean or univariate. You can check it. So you can continue now. Classify. All group equal. And you can have compute from group size not required. Summary table, you can have summary table. Within the group. Okay, it's fine. Replace the missing value with its mean, or you can remove the missing value. So whatever you can do it, replace with the mean. Continue. Then you can enter the independent variables. So now make it okay. Or if you go for paste, okay, it's not required. So code the values, no. Okay, then say okay. So if you say okay, then we will have the values. This is the result. So directly go to the, here is the group statistics. So our objective is there are 3 outputs: outdoor, social, conservatives. So all these men based on different values. How many are there? How many totals? All these things. So it is only the descriptive statistics. Then go for here. That is the main things. Test the equality of group mean and pulled within group matrices. So these are the things we will go one by one and discuss what is the significance of all these things to analyze the results. Comes to the PPT now. In that PPT, we'll discuss all the results. Okay, the first come the ANOVA table, the test of equality of group mean. So if you see that the significant value is all less than 0.1, means it is less than 0.05. That means the smaller wiki values lambda, and more importantly the independent variable to the discriminant functions, wiki lambda is significant by the F test for all independent variables. That means for all independent variable has a significant impact on the output. So here everything should be less than 0.05. Then correlation matrix. You see that correlation of different independent variable. As I told that means correlation must be less than 0.4. So you see that the correlation between outdoor and social is 0.079. Correlation in outdoor and conservative is 0.00. It is very less. Means there are least interaction between these variables. That means there is very less chance of multicollinearity in the data. But you see that the output, the test of homogeneity of covariance. Test of homogeneity of covariance, it says that the larger the log determinant here, log determinant, here whatever given, that value log determinant, whatever value is given, the more that group covariance differs. The rank columns indicate that number of independent variables in the case. Since the discriminant analysis is assuming the homogeneity of the covariance matrix between the group, we should see the determinant must be relatively equal. So for that, we have the significance of box M values. Okay, so you see that in the values, that all values here in the box M, that is significant, that is 0.0501, that is less than 0.05. Sir, output summary of canonical discriminant functions. There are two functions because there are three output. So three group means one is reference group. That's why there are two equations. Here the reference group is the last one. That is third one. Third one, that is the reference group. So that's why we have only two equations. That is equation 1 and 2. The equation 1 and 2, the relation correlation coefficient, that is the canonical correlation is 0.7, 0.4. And that is, here you see that with Wilkes Lambda test, that is all significant. That is most important. That means two equations can be used to classify the variables in the output, and it should be significant. When there are two groups, the canonical correlation have most useful measure in the table, and it is equivalent to Pearson's coefficients. Wilkes lambda is the measure of how well each function separate these groups. Smaller value indicate greater discriminability of this function. So most of them, it is very small and it is also significant. That means the algorithm has significantly distinctly classify the output. So you see that here it is that standardized decision function. These are the functions. Standardized means this is the coefficient of the equation. What we will get out of the discriminant analysis. So to predict, you have to create an equation. In discriminant analysis, if there is more than two output classes, we have different number of equations. As we have three output, so we will get two equations. So one equation, the beta value is 0.79, 0.3.1 minus and 0.517. Another equation, the value is 0.926, 0.21 minus 0.291. Generally, if the loading is less than 0.3, we don't consider this. So we see that the equation 1, all the coefficients are greater than 0.3. That means to predicting a output, the equation 1 has more significant than the equation 2, because in equation 2, some of the coefficients are less than 0.3. So based on that, we have created two equations. The first equation having all the first function, that is 0.097, that is the constant, plus outdoor score plus social score, like this. Second function. So these two functions is used to determine the output of a new set of variables. So how do I find out this? Suppose I take two functions. That means two values, that is A, that is the first independent variable, second and third. And using this, I can put the value of A, B, C into this equation. A for outdoor, B for social, C for conservative. So I can put this value into the equation. I will get F1 score will be minus 1.248, F2 score will be minus 0.088. So with these two values, how can I find that? So that means my new data comes under which class? Class 1, class 2 or class 3? So that is dependent on the nearest, that means which of this group is nearest to this point, that is 1.248 minus 0.808. This is nothing but the new centroid based on the new data. So if you find out these values and relate to that, you could find out that these two values is nearer to this here. That means 1.94 onto this. Means that new variable comes under group A. And that what is group A? That is customer service. That means if I give the new data like outdoor 10, social 20, and conservative 5, based on this value, that person belongs to the group which is called group 1. That is called customer service. So in this way, you can determine or predict the new variables to the output variables. Right? Okay, so then comes to the classification. So in the classification, you can see that the performance of that, you can see that written here 75.0 of original group cases classified correctly. So the accuracy of our model is 75%. And you can find out other aspect like the sensitivity, the specificity, the F1 based on different tips. So one of the example is given here. So for that, you have to first find out true positive, false positive, true negative, and false negative. Once you got all these things, so you have the equation. I already discussed the equation. Using all this equation, you can find out the score for F1, the score for accuracy, the score for sensitivity, all these things you can find out. So I hope you understood what is the difference between logistic regression, binary logistic regression, and discriminant analysis. So how do I calculate the prediction of new variable, and what are the different performance indicators which say how your model is performing. So now if you have any questions, you can go for it. So Sudipta, now it is up to the participant to ask if any question.
Hello, am I audible now?
Yes.
Yes. Any question? Any question from the participants? So you can unmute yourself and ask any question from your end. Please stick to the today's topic.
Sir, am I audible?
Yes, yes, please.
Good evening, sir. I am Ajay Kumar Yadav from Bharatiya. I think you know me very well. This is my second class here. Sir,
Okay.
actually, I want to ask about in logistic regression, the interpretations of the coefficient and validation, and how we testing the significance level.
No, you see that there are two things. First one, that means logistic regression. In the logistic regression, the significance of each variable depend upon the p values of that. If you go for logistic regression, here I can say that WALD test, WALD test, WALD test p value. If the p value is less than 0.05, means that variable has an impact on the output variable. That test, that is for individual. As a group, you should go for the chi-square test. In the chi-square test, p value must be greater less than 0.05.
And sir, my second question is the how we formulate the problem in conducting the binary logistic analysis.
So the first most important point is that your output variable must be a category variable and should not have more than 2 categories. Like that, if it is more than 2 categories, you cannot, you should not use the binary logistic regression. There you can either use multinomial, or you can use discriminant, or if that output variables have order, you can use ordinal. So there are other options: ordinal, multinomial, or discriminant.
And
Discriminant
sir,
when all the
um,
independents are numeric.
and sir, my third question is how we estimate the two group discriminant analysis, not single group, two group discriminant analysis, and how we
No.
estimate the binary logistics model.
If there are two groups and independent variables, the independent variable does not have any category variable, then it is better
Okay.
to go for discriminant. If the independent variable has an category variable, then you must go for binary logistic. Don't go for discriminant, because discriminant never analyze properly the independent category variable.
Okay, sir. Sir, suggest any standard book according all these topics.
So
Please
nowadays,
mention writer's name. Sir,
nowadays,
author name.
nowadays, you can have lot of materials. If you ask them, then you can go for that by what's his name? Just forgetting. So one of these book you can go for. I have some references here. You can go for
I
this.
follow sir Naresh Malhotra and
Yes.
Das.
Naresh Malhotra, that is marketing research or business research method. Which
Yeah,
book?
marketing.
Marketing research. That is also, you have all these things there. You can have also Zygmunt. Zygmunt also a good book. You can use that. Okay. Any other question?
Any other question you have? If you have any question, please ask. Any question from your end? Sir, you can stop sharing your screen now.
Okay.
I think there is no further question from any participants. So today we will end our session here, but before that, I will request our faculty member, respected faculty member, Professor Nilay Sharkar, to give vote of thanks to today's research person, Dr. R.K. Jena. Nilay sir, are you there?
Yes, sir, I'm here. Yes, sir. Just a minute.
Yes, sir, please.
Yeah, good evening to all.
Good evening, sir.
Good evening. Thank you, Dr. R.K. Jena. This was really one excellent session. You have explained such a complicated topic, discriminant analysis and logistic regression, in such a lucid way. I would like to request Dr. Ghosh to conduct more such sessions with you, which will definitely help us, the researcher like us, and also academician like us. Now, I would like to thank our director, sir, Dr. Subramaniam, and our principal, sir, Dr. S.P. Mohapatra, for their constant support to conduct such FDPs. Last but not the least, I would like to thank you, Dr. Our own very own Dr. Sudipto, for conducting such FDPs. Thank all the persons who are associated with such endeavor. Thanks a lot, Dr. Jena. Thank you.
Thank you very much. Thank you.
Thank you, Nilay sir. And one more request to all the participants, please fill up the feedback form. I have already provided the link in the chat box. Yes, you will definitely get the PPT and video recordings if everything is as per the plan going, and you will get definitely the recordings in future after completion of this course. So no need to worry about it. So we have to check different technicalities regarding the recording of the whole session. So after checking all the things, we will definitely share the video recordings with you, and all the materials like PPTs and all we will collect from all the resource persons, and definitely we will share those things with everyone. Okay. So again, thank you, Jena sir, for giving your time and accepting our invitation. So we'll close our today's session after taking permission of our principal sir. And to all the participants, we will meet tomorrow in the last session of this 5 days FDP. And tomorrow, please remember, tomorrow we are going to start the session from 6:30 p.m. half an hour before, because Dr. Gautam Bandabadhyay from NIT Durgapur, he is going to take the session from 6:30 onwards. Okay. So please be there from 6:30. I definitely send you a reminder email regarding this matter. And I hope you will be there from 6:30 tomorrow. Thank you very much. Thank you very much. Good night. Bye. Thank you, sir.
Thank you very much. Thank you.